Today we will be looking at section 6 of chapter 4, which is dealing with congruence in right triangles. So up to this point, we could have any kind of triangle. Today is focusing on right triangles. So we're going to be able to prove right triangles are congruent using the hypotenuse leg theorem, which is abbreviated HL. Okay. So key thing to remember with this formula is that it only works for right triangles. So when you look at that piece in your interactive notebook, it tells us that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So with this, even though we only have two letters that we're using, the H and the L, there are still three things that we have to see in the picture. Okay? We have to see that we have right angles, because again, this only works for right triangles. So we have to see that they're right triangles, that we have right angles. Okay? The hypotenuse. How do I know which side is the hypotenuse? It is opposite of the right angle. So I have the hypotenuse. Okay? The other two sides are the legs. I have to have one set of legs marked. So again, even though we're only using two letters, we have to know that we have right angles. That's enough then to be able to say the two triangles are congruent. Then the other piece that you have in your notebook is a piece that says not congruent. There are several different combinations that we have not looked at as one of our shortcuts because they do not work. Okay. So these two situations you want to fill in on that piece in your interactive notebook. Okay. One of those that does not prove congruency is side-side angle. Okay. We have a side angle side, so if the angle is between the two sides, we can prove they're congruent. But if the angle is not between the two sides, like you see in the picture, you cannot say they are congruent. We do not have a side-side angle shortcut. The other one, which I've seen some of you write down, even though we never talked about it as being a shortcut, because it is not, is angle, angle, angle. Okay. If we think about equilateral triangles that we talked about yesterday, okay, all the angles are congruent there. I can have a very small equilateral triangle. I can have a very large equilateral triangle. The angles are congruent. The sides are not. Okay? So those are the two combinations that do not prove congruency. So we need to remember those. Okay, cannot use those. Only the 5 shortcuts that we have there in our notebook. So to finish out this section, we've got 2 proofs that have not yet been done in your proof book. We had skipped those pages earlier. So, again, we're going to start out with that first given statement. Angle or triangle QSR and triangle TSR are right triangles. That's a given. So I need to mark that in my picture. So if those are right triangles, that means I have right angles. My second given is that segment QS is congruent to segment TS. So that is another given. Then we have that shared side. So SR is congruent to SR. That's our reflexive property. So when I look at my picture, I have three things marked. Is it the right three things? Yeah. Okay, so I have right triangles. The hypotenuse are congruent. That shared leg is congruent. So I know that triangle QSR is congruent to triangle TSR, and that's my hypotenuse leg theorem. So again, when I look at my proof, I only have two congruent statements. When I look at my picture, there are three things marked because of that first given telling me that I have right triangles. So I know I have that right angle that I need for hypotenuse leg. Second proof. First given is that PR is perpendicular to SQ. Reason is given. So what would I have to do next? If you're looking down below, am I told I have right angles? No. Nope. I'm told I have two segments that are perpendicular. So how does that help me? Now, using this given statement, look in your proof book down at the bottom where they have those boxes. So what's going to be my next statement using that given?
Angle PRQ and
Okay. Angle PRQ and angle PRS are right angles. How do we know that's true? I'm saying they're right angles. How do I know I have right angles? What am I going to use from my choices down below? Definition of perpendicular. Okay. perpendicular lines form right angles. Now looking below, what can I do knowing that those angles are right angles?
All right angles are PRs can use
You state your
PR is congruent to PRS.
Yep. Angle PRQ is congruent to angle PRS. Okay, need to be looking at your choices down below. Okay, so how do I know those two angles are congruent? All right angles are congruent. We used that in that proof we checked yesterday. So that used that given. Now we can say PQ is congruent to PS. That's our other given. Okay, then we would have our shared side. PR or RP is congruent to itself. That is reflexive. And then we have our three parts. So triangle PRQ is congruent to triangle PRS using hypotenuse leg. Okay. So that particular proof, if we were doing it all by ourselves, we might do that a little bit different, okay? Similar to some things that we had talked about yesterday with our proofs, okay? They're really getting specific step by step, okay? We might not have written this second step. We could have done without it, but because this was set up to match using the pieces below, that is how you would have to process through it. Okay? So if it's a fill-in parts, like we typically see on our quizzes and tests, okay, if it's fill-in parts, you would need to be able to process through like we see here. If it was one that you were completely doing on your own, we probably wouldn't write in that middle step. Okay. So that is it for this lesson on using the hypotenuse leg theorem.